Okay, so okay, so last class we stopped at variance and sample, variance and standard deviation. So this one. The quiz will cover more or less your homework. So I only suggest you complete the homework before that day. It will be very, very helpful. I'm going to be picking the question literally from that homework. But of course, I'll change the numbers and make it different from the homework, but the content will be matching very closely. So if you finish the homework before then, it will really be helpful. Okay, so we started last class with the formulas for, or we start last class working on the formulas for standard deviation, okay? And so we said like mean. Okay, so we said like mean. There will be quite some formula in this class, right, as we go along. But there will be a formula sheet, of course. And during the quiz, you can actually bring a copy, like a cheat sheet, like 1 page, right? I'm going to send detailed email containing instructions about it. So we started with the mean last class, and we talked about the sample mean. So the sample mean here is X bar, right? And it's giving us sum of all the data. Okay, I'm using Xi to represent the data, divided by how many data points you have. And we're using small letter n to represent the sample mean, right? So here, I will be 1, 2, 3, to infinity, right? Whatever you can count on. So I have xi1, data 1, xi2, data 2, xi3, and so on. And the population terms, you use mu as your symbol for mean, and it's also giving us sum of all your data points. And I'm using capital letter N here, representing population mean, population number, total number of data points you have in your population. But last class, we started with a derivation of frequency distribution, right? As mean, I have a frequency, right, where a number of data points repeated. The mean could be written, and we're focusing on sample mean now, because as we explained and as we see, the symbols, I mean, the formulas are the same. They will always give you the same thing for mean, right? So the sample mean here, if I have a frequency distribution, it's given us sum of frequency times data divided by the sum of frequency, right? And we tried to explain this by derivation last class. So if, for example, I have this set of data, for example, I have a data point to be 1, okay, 1, 3, 5, another 1, another 3, another 3. Okay, for example, let's say I have this as my data point. Let's keep it simple. I could do the mean as sum of my data points, right? Which will be 1 plus 3 plus 5 plus 1 plus 3 plus 3, right? Divided by the number of items I have, 1, 2, 3, 4, 5, 6, divided by 6, right? So this gives us anybody totaling this, the numerator? That will be 4 plus 5 is 9, 10, 5, 16. Is that correct? Okay, thank you. Enter multiply that. So help us with calculator here. 16 divided by 6 will give us. Anyone close by, or do we pull up on the screen? Okay, so 16 divided by 6 will give us 2.667. So let's say to 2 decimal places, we should have we have 2.67. Right. So what we're saying is that the formula for mean can also be this one here, right? The frequency distribution formula. So if I have actually rearranged the data, and instead of presenting it as discrete values this way, if we have the data arranged in form of frequency. So this is all your data. I have 1, 3, and 5. Those are the only 3 data points I have, uniquely, right? Then if we have the frequency column here, okay, I'm going to be representing that with F. Then there are 2 1s. There are 3 3s and only 1 5, right? So if you do the frequency times the data point, say column here, then I'm going to have 1 times 2 is 2, 3 times 3 is 9, this is 5. Okay, so if we sum up this column, so if I do the sum of frequency times each data point, we're going to get exactly 16, which is something as the numerator we have here, right? If we do the sum of the frequency, we're going to get exactly 6, right? So this is 6 and this is 16. So if you match this, it's like saying you can actually solve the same problem by seeing that this is the same thing as this, right? And what color do I use now? Purple. And this will be the same thing as this one, right? So if that is the case, then the formula can effectively be replaced. So we now have 2 formulas for solving, calculating the mean. So we have sum of all your data divided by sample size, right? Or we could use sum of the frequency times the data point divided by sum of the frequency. All right. So if you have a question that gives you a frequency distribution, then this second formula is easier to use than the first one. Okay. So such a scenario will be if I have something like you just have a table, you have xi and you have frequency here. You have 1, 5, 7, and maybe 3, 8, 9. I'm saying find the mean of the distribution. Then you're using the second one to be easier. But if you want, you can also say, okay, I can write all these one out. This is 1, 1, 1. That is 3, 1. This is 5, 5, 5, 5 into 8 places. And this is 7, 7 into 9 places. Then add all of them together. I mean, you can still do that, right? But this one is more compact and better than that. So we worked on that. Any question on this? I was doing a quick recap. Okay, so before we left, we were working on variance and standard deviation. So again, we continue with the notations, right? This is sample and this is population, and this is where it matters, right? In mean, it doesn't. In mean, essentially, you have the same thing. So for sample variance, it is represented as x squared, right? And let me write that in parentheses, that is variance. Okay. In the sample space is given as the sum of your data minus the mean squared divided by n minus 1, right? But in the population space, the symbol is sigma, right? Sigma square, and is given here as, so we'll be using the population symbol here. Each data minus the mean square divided by population size minus 1. Sorry. Okay. Divided by 10. And so you see these adjustments. And again, if the sample is very large, these two formulas will give you the same answer, right? Like we saw in percentile. But if the sample is small, then you get different answers from this item. So the adjustment is just to correct for sample size. This negative, minus one that you have on the sample equation. Okay. So that is variance. And the standard deviation here is written as S. I'm going to be using SD to represent that to make it short. Right? And it's just the square root of whatever you have as your variance. So if you're asked to calculate standard deviation, you will need to calculate the variance and then just take the square root. All right, so this is the case for sample. For population, the same thing, that's the square root of whatever you have as the formula for standard deviation. Okay. So this is where it matters a little bit that you have population and you have standard, you have sample formula and you have population formula. For the mean, it doesn't matter. You're going to get the same result both ways. All right. So let's take an example on this one. So let's assume I have simple data and let me change the color to red. Let's assume I have simple data points like this one. Let's say we have 2, 8, 5, and 4. And the question is find the standard deviation. Find the standard deviation. So if you look at the formula, so if the question doesn't say find population standard deviation, automatically it's asking you for sample. All right? But if it says find population standard deviation, then you're solving with population formula. But if it doesn't say, it's automatically sample that you're dealing with. Okay? So find standard deviation here, we're talking about find sample standard deviation. So essentially, we're going to implement this formula here, right? We're going to do it two ways. We're going to work it out literally horizontally, and then we create a table to make it compact. So working it horizontally, you see that first you need to find the mean, right? You know your data points, xi. Each of these are your data points. There are 4 of them, right? And you know your n, there are 4 of them, 4, right? And what you don't have right now is the mean. So you want to work that out first before you start computing. So your mean, of course, is sum of data. Divided by number of data, right? So this will give us 10 plus that is 19 divided by 4. Anyone with calculator close by? 19 divided by 4. 4.75. 4.75, thank you. So we have 4.75. So that is your mean. So you want to get that out of the way first. Then you go ahead and implement the formula for standard deviation. Our standard deviation solving just the way it is will be if data, the first data, which is 2, right? Remember, I here represents all the number of data you have. So xi1 is the first data, xi2 is the second data, until you get to the end. So if we're implementing this formula, we do the first data minus the mean, 4.75 square, and then you're summing it up. This one here, right? So you sum, you go to the next data, it is 8, the mean, and then you're summing up, plus the next data point is 5 minus the mean, then you're summing up, square, and then the last one is 4 minus the mean, and you're summing up. So you're summing up everything, that is the summation symbol here. And when you're done, you are dividing all that by n minus 1, which is 4 minus 1, right? So you're doing this literally, should have used a number that is a whole number here for the mean to make it easier, but we'll go further. So 2 minus this will give us 2.75 raised to the power of 2. If we could have two people using calculator to help us, so we just confirm each other.
I got 7.56.
7.56. Thank you.
How many decimal points do you want?
Okay, so that is important, right? So when you're doing this homework, I would say keep up to 4 digits, right, to be safe. And then when you're done, before you input your answer, look at the instruction and round off to the answer the system wants, right? If you round off early enough, your value gets to be wrong at the bottom, okay? So 4 is normally safe. I don't think there's any question on this system that asks for more than 4 digits. Okay, so let's say we're using 4. So please go ahead.
7.
Collins, right?
Yes.
Yeah, please go ahead.
5625.
5625. Thank you. So did you square? You did. Okay. See. Oh, yeah, you squared. Yeah. Okay. So that would be that. So what we did here is 2 minus 4.75. The result raised to the power of 2. Right. The result multiplies itself. So we have this value here. Then let's go ahead to the next one. And please, someone else should be working this. If you catch anyone wrong, you let us know, please. Okay. Let's continue. This next one, of course, is 8 minus 4.75 raised to the power of 2.
10.5625.
10.5625. Thank you. Please also keep cross-checking each other. So if we get anyone that does not match, and then we go ahead to the next one. 5 minus 4.75 raised to the power of 2.
0.0625.
0.0625. Thank you. And then the last one, 4.475 raised to the power of 2.
0.5625.
0.5625. Thank you. So if we have all this and you're dividing them by 3, right? We could do with addition there. Okay, let's see if we get 2 answers, right? From 2 different persons that matches, then we'll take that to be 7.625 plus 10.5625 plus 0. I think if you got an answer, let us know, please.
I got 6.4375.
6.4375. Thank you. Do we have anybody confirming this?
Also have it square root.
Oh, the square root. Okay, so okay. Thank you. So this is what you have after taking square root or before?
Before.
Before, okay. Okay, so and that is okay. So that what you've got now is this variance. Okay. So that essentially when you're asked to calculate the standard deviation, you have to get the variance first, then you take the square root to get the standard deviation. Okay. So that our standard deviation.
6.2.
You don't have that. What do you have?
I got 6.25.
6.25. Okay. Can anyone confirm?
I got 6.43.
Okay, so we take the one to and these things are it's pretty easy to miss.
0.0625.
0.06.
0.6.
This is is
So
it
it's-
0.06?
It's supposed to be
It's
0.06.
It's supposed to be 0.062.
Yeah.
Okay,
So
thank you.
then it's 6.2.
Okay, so next time we're gonna pick a time to get a mean that is just 0.0625. A mean that is just a whole number so that we don't have all these decimals. Okay. Can we confirm that if we do that, the answer will be 6.25? Okay. Anybody else confirm? Okay, so that's
That's 6.437.
6 points.
I got 6 points.
Yes.
6.2. Okay, so we have many people getting that. Let's go with that. Yes. And what I'm trying to illustrate is the process, right? So 6.25. So if anything turns out to be wrong, I believe you're following the process, and that is what is important here, right? So the standard deviation would then be the square root of whatever you have as the variance, 6.25, and that gives us 2.5%.
2.5.
Yeah, thank you. So we have that as the answer to that. Okay. Any question here?
Is there like if we have like a large amount of numbers, is there like a faster way to do it?
Unfortunately, oh yeah, there are other formulas that are shorter, right? But I wouldn't want to go emphasizing that right now. There are computational formulas that are shorter than this one, because like the goal of this class is not really to do this hard computation, but what the hard computation is doing to show you the process behind. Towards the second half of the class, we're going to be using SPSS to implement. Okay, yeah, there is a shorter, a quicker one. And one thing you can also do is to maybe arrange this in a way that will make it better using a table. So you have xi, that is your data. Rather, let's do data minus the mean here as the first part, and then let's do data minus the mean square here as the second part. And if you have this way, it becomes much more straightforward, right? So if you do the first part, you'll be having data, and I'm not going to write all of them out, data minus 4.75, which is your mean, and then you square them this side, you're going to get 7.5625, right? And then you do the next one, of course, that will be 854. So 8 minus 4.75, you square that, you're getting 10.5625. And you continue the same thing, just the way we did, right? So if you square the next one, you're going to get 0.0625. You square the last one, you're going to get 0. So I'll just put that. Yeah, 0.5625. And the formula says that you should sum what you have as data minus the mean square. Formula says sum that. So that simply means sum this column, right? So if you sum this column, of course, you're going to get the value we got, which was, okay. So let's say sum this column and then divide by n minus 1. There are 4 data points, right? So your n minus 1, of course, will turn out to be 3. Okay, so this will be n minus 1. So if you sum that column, this column over here, you're going to get, I didn't write it down. Okay, so, but you get what we're doing. So anybody have a sum of this one somewhere? And I can actually, okay, no, that is right. You can do 6.25 times 3. That is like 22 point something. 21.75. 18.75. Is that what you have? 18.75 divided by 3, right? So you end up getting the same value as we have, which is 6.25. Now, this is where the mistake often happens. You remember that this formula is for variance, not for standard deviation. So for standard deviation, so this is variance, right? For standard deviation, which is represented with S, you want to take the square root of your variance, and then you are getting the same final answer. So this is more compact, right? You can arrange it that way and still get to the same solution. Any question on this? Okay, so we are moving ahead to the Z. Okay, so I think I will share the review video for everybody after this, like the last one and this one, right? Just in case. So first of all, let's talk a little bit about the Z distribution. Just very briefly, we're going to meet it again when we go into maybe next 2 sections. The Z distribution is something like this, right? And it's standardizing the numbers. I'm going to talk more about that standardization later on. You have positive values on the right-hand side, and you have negative values on the left-hand side. Negative value doesn't mean negative value. It simply means the value of the data that is below the mean. And positive value means the value of data that is above the mean. The mean will turn out to be 0. Okay, and we're going to talk more about this later on. So, but for now, what we are interested in today is just basic introduction using the formula that Z is equal to your data minus the mean divided by the standard deviation. Right, and we can write the population version of this formula, but it's just like the mean, the population version and the sample version comes out to be the same thing. So for the population, you have that Z is equal to your data again minus the population mean divided by population standard deviation. It's just a simple difference, right? Population difference. Okay, that's okay. So essentially, both of them gives you the same thing. So we're going to focus on the formula on this sample formula. So the first question here says, the mean for men is 69.2 and their standard deviation is 2.68 inches, right? The question is, if a man is 6 feet 3 inches tall, what is the Z-score? Okay, so you can see how we got this value. But one I want to point out here is, look at the height of this man that is given. It is given in feet and inches, but the data we are given over here is all in inches, right? So you want to work in the same unit, so convert everything to inches first. So I could take 6.6 feet and convert that to inches by multiplying by 12. Isn't it? Because 1 feet or 1 foot is 12 inches. So if you multiply that, you get 72. Is that correct? 27, yes. Okay, so this is 72 inches. So this man here is essentially 72 plus 3 inches tall. That is a total of 75 inches. Okay, so that in the formula, that is what you work with. You do the same thing for the woman and you calculate the Z-score. So we're going to focus on that of the man. And then in the next section, we'll have opportunity to try this out. So the Z value here, let me write here. That will be, so we're trying to implement this formula, right? So I'm going to take Xi, which is the individual data point, Xi, so that is 75 inches, minus the mean for men, which is 69.2, divided by the standard deviation for men, which is 2.68. Okay. So I pause quickly here. Let me be faster than what I'm doing. So anybody got an answer? Say louder, please. .2.16. Can somebody help confirm that?
Yeah.
Yeah, thank you. So we have 2.16, and that is the Z value, and that is what we have here, right? That our answer was rounded to 2 decimal places. So we pay attention to the instruction. The instruction here says 4 decimal places, but we're okay. I mean, we know what we're doing. We're just working this. So, but when you're doing your homework, of course, you know, you can try as many times as possible. So if you make mistake by rounding wrongly, you can just redo it and get it right. That's this one, the instruction will always pop up to tell you what to do. Okay? So that is what we have. And the same guys, exactly the same way you calculate for the woman. Right? Again, remember the key thing is pay attention to the units. You need to convert, make sure you're working with the same unit. Right? So you want to first convert this one here to inches first, the way we did for the man. Then you use that in your formula. Right. Okay, so the other thing to pay attention to is that you just switch this, right? The data comes first before the mean. Right? If you switch it, you get a different value altogether, which will be technical, which will be wrong, not technically wrong. It will be entirely wrong, right? Because it will place this individual below the mean. And what this individual is actually above. Okay. Any question on this one? I'm going to leave out this one. You can confirm that since the answer key is here, you can confirm that on your phone. Okay. We'll try to catch. Any question on this one? Okay, so we will have class work here. I'm gonna do the first one and then you model that to do the second one. So I will do 3A, we do 3A together and you do 3B. Okay? So for 3A, I was asking you a slightly different question from the first one. It's also demanding that we use the formula Z is equal to data point minus the mean divided by standard deviation. But it's giving you standard deviation this time. And it's asking you for the individual data point. So here it says another two-man height is, or adult women in population, their height is, the mean height is 64.6 inches and their standard deviation is 2.45. So find the height of a woman whose Z-score is 2.73. So in this case, you are giving the Z-score. So we just go ahead and implement the formula, right? My Z is 2.73. This is equal to, we don't know this value. That's what we're looking for in this instance, right? And then we know the mean to be 64.6, and we know the standard deviation to be 2.45. So we just do a cross product. A little algebra to get what we need. So you can do this anyhow you wish, but I will illustrate it this way. So we are multiplying across. If you have a quick way to solve this, I know there are shortcuts. If you have a quick way to quickly solve this, do that. You don't have to do what we're doing right now. Okay. So if we multiply across, then we have that xi minus 64.6 is equal to 2.73 times 2.45, right? And so if you add 64.6 to both sides, then this will go away. So you get the height that you're interested in. Right, so that height will be solving this. Please help us do this. Let's see if we can get 2 answers. So 2.73 times 2.45, then you add 64.6.
Two,
0.29, okay.
or it would be 8.
Okay, it should be 2885, right? So I need to know. Okay, we can do with 2 decimal places here, that is okay. Anybody confirming this one for us? You got this one?
Yeah.
You got some, okay, good. So we have 1.29. Okay, so apply what we've just done to do question B. Pay close attention to the signs. Anybody who has not used the attendance sheet? If you need my attention, let me know. I'll come across and work with you. But otherwise, just try to see if you can get the answer to question B. We'll take like 3 or 4 answers Anyone who has not marked on the attendance? I think we are 15 and I have 14. You've not?
No.
Okay. Okay. I'll try to get your names. What's your name, please? Proc. Pro. CK. CK. Okay, Proc. Have you marked? Yes. Okay. Anyone else? Okay. Okay, if you have an answer here, let us know.
60.0999.
60.0999. Thank you. 60.0999. Then which will round up to 60.1, but let's keep it at that. Okay. Anybody else got something different or the same?
I got the same.
Okay. Almost everybody's saying the same, so we're gonna stop. All right, so that means you paid attention to the sign, and that was good, right? Because that's what takes people in questions like this. But just for avoidance of doubt, let's go ahead and work it together very quickly. So we are implementing the formula. We have that. Okay, let's start with z. We are using that z is equal to xi minus the mean divided by standard deviation. And so we have z here to be negative 3.1786. And we are looking for this individual's heights, but we know the mean to be 69.0. You know the standard deviation to be 2.8. Right. So again, you do cross product, and that gives you that xi is equal to cross product the way we did it, right? Is equal to negative 3.1786 times 2.8, right? Plus 69, right? And I want to believe that this will give us that answer, 60.0. Okay, any question? Okay, so that is just that. So just pay attention to the negative sign and how it affects your results. Okay, so with this, we are done with section 2.2 and 3, right? And we didn't solve everything. We just picked key questions that will enable you to take care of that homework. So if you've not completed it, please do the homework. It has percentage on the overall grade, but more importantly, your quiz is going to be coming from there. Literally, I'm fixing it again, but I'm going to just pick questions and modify the numbers, but it's coming from that pattern. So if you get used to solving those homework questions, you will be okay with the quizzes. Okay, yes.
So you said we can have a piece of paper.
Yes, so I'm going to send you that in an email instruction. You can have one page having the formulas you need. Okay. And then, sorry. Sorry.
It's on my open math.
There is a formula on my open math.
No, not the formula, the quiz.
I'm going to send it up. There is one, but you can access it until the date of the assessment, right?
Yes.
Is there one right now there?
No, I was just wondering if that's where we were doing it.
We're going to be doing it up in the lab. Oh, not up again. Across the hallway here, 342.
But it's going to be in the program, My Open Math.
Yes. Oh, that is your question, right?
Yes.
Yes. So when we come in, you're going to come in early, try to come in like at least 10 minutes before class. I'm going to randomly assign everybody to a seat, and I'll put numbers on the desk. So you look at the screen, you see where your name and your number matches, you go to that computer, right? Once you get in, log in, so that immediately it's 9:30, we get started. So I can use just 45 minutes to be done, and then we'll come back here and continue. Okay, but I will send detailed instruction later on before then. Yes.
Should we bring like scrap paper and things, or will we
Yes, you can get like scrap paper as much as
able to use?
yes. as much as you want, I don't mind. Right, please, if you are coming with a, I don't really care about the kind of calculator, come with your calculator. You can use your phone, right? So use your calculator, don't use phone. And I'll think through this more properly and send you more detailed instruction about it. Okay? But the fundamental thing is really coming and going straight to that lab, not the class here, so that, and then coming early to log in so that by 9 you can all get started, so we can save some time. All right. So if you don't do the homework and then you end up doing it after the quiz, you're going to feel bad because you see that would have helped you in the quiz. So please do complete it before then. Okay. Okay, so let's move ahead to this section 3.1. Hopefully we'll be able to cover it. So this is 3.1 and 3.2 joined together. They are both probabilities. So probability is simply the number of times an event occurs versus the number of times that is expected to have occurred, right? So if I just flip a coin and I'm expecting a head, I could have had a head or a tail. So the probability of a head will be 1 out of 2, right? If I'm flipping a die, so this is for a coin. If I'm flipping a die, a 6-sided die, right? I could have the probability of getting a 6, right? There are 6 sides, there are 6 numbers, right? So, but there's only 1 6, so there's only one of those 6. Okay, let me write it the way I wrote it down. There's 1 6, and there is 1, 2, 3, 4, 5, 6 possible items coming up, right? So the probability here is 1 out of 6. It's just very basic and very straightforward. We're not going to go into complex kind of probability. That's not the goal of this class, right? But one other thing to note is that probability is ranges from 0 to 1. Okay. So 0 meaning you are certain the event will not occur. 1 meaning you're certain the event will happen, right? So if there is a 0% chance that it will rain today, then we are 100% certain that it will not, or that it will rain today, right? If there is 0% chance that it will not rain, then we are 100% chance that it will not rain. Whatever value you get now goes in between. So you can present your probability as a fraction, or you can represent it as a decimal number, right? So that numbers ranging from 0.1 could be something like maybe 0.75, right? 0.8, right? And 0.75, I can also write as 3/4. So if that is my probability, I can keep it in this form or keep it in this form, right? Let me use a number that would be easier to pick up. So 0.25, I can also write as 1/4. I keep it in fraction form, I can keep it in decimal form. So you can use any of these 2 forms for a probability, but probability can never be outside the range of 1 because you can't be more than 7. 7 is the best you could do. So if I'm saying there is 200% chance that it will not rain today, then I'm just exaggerating because I can't go beyond 7, right? Okay, so that's something like square root of any number is not a proper probability. Something like a negative number, even if the form is correct, is not a proper probability. The probability had to be from 0 to 1. Okay, so that is just a general introduction there. As you're doing the homework is meant to also help like emphasize or teach this formula. So some question will have like a video attached or a textbook attached, but the ideal thing really is that you read the textbook for that unit, the textbook chapter for that unit, and then you come to do the homework. And if there are videos, you watch the videos and you do the homework, right? So whenever we come to class, I will be taking sample questions on the homework this way, or critical questions that will kind of give us idea of what the topic is talking about, the concept, and we'll discuss it in class. Okay, so that'll be important. So sample space, a sample space is simply all item in that space. So for a die, for a 6-sided die, the sample space will be all the numbers that is possible. So I have 1, 2, 3, 4, 5, and 6. And that is the sample space for the 600. So it has 6 elements. So we could say that sample space has 6 elements. Okay. Let's go ahead and solve our actual question using just the few things we've gone through right now. So the first one here says the special deck of cards has 6 red cards, 5 black. The red are numbered 1, 2, 3, 4, 5 to 6. The blacks are not, the black cards are numbered 1, 2, 3 to 5, right? So R, it represents red card and it represents even numbered cards, right? So probability of getting a red card will be represented as PR, right? And probability of getting an even numbered card will be presented as PE. Okay, so those are just straightforward notations. The first question says, how many elements are there in the sample space? So